Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Pie Path, and it's by Certified Paint Freak. Okay, hopefully you're not sniffing too much paint because then that would cause some problems, but otherwise, enjoy your paint. Here are the rules. Starting on the green circle and ending on the red circle, make a path of orthogonally connected cells in which the digits are in the same order as the first several digits of pi. That is, the first digit on the path is a 3, then 1, then 4, and so on. The path may touch diagonally, but not orthogonally. Okay, so we have to create a path from this green cell to the red cell. It's all orthogonally. Yes, orthogonally connected cells, which means that they have to share an edge with the next digit on the path. The next cell in the path. So it could be something like this. This is a valid path. And it has to be basically the digits of pi. So it would be 3, oops. This would be 3, 1, 4, 1, 5, 9, 2, 6. Well, for convenience, here are the first 30 digits of pi. You do not necessarily have to reach the 30th digit. So it could be like that. 5, 3, 5, 8, 9, 7. So this would be a valid pi path, except that it would break normal Sudoku rules. Oh, it doesn't even say. I'm assuming this is a normal Sudoku rules apply, because otherwise it doesn't make any sense. So normal Sudoku rules are that you have to fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or box. And then you must create a path from the green circle to the red circle, all of which contains basically the digits of pi in order. So that should actually limit things there. And the path can touch itself diagonally but not orthogonally. So what that means is, for example, you could have something like this is valid because while it touches itself diagonally, it does not touch itself orthogonally. But something like this is not allowed because it would basically go out and then touch itself again. Which orthogonally just means that they share an edge. And this is not valid as a path. In box X, the first digit, top left cell in a box. Oh, interesting. So in each box, in box X, we number the boxes by convention in normal Western notation, or actually I should say typical Western notation reading order, which is left to right and top to bottom. So this would be box 1, this is box 2, etc., etc., 3, 4, 5, 6, 7, 8, and 9. In box 1, the digit in the top left cell in the box, so that cell, tells you the index of the digit X in that box. So in box 1, this digit tells you what the index of the digit in that box is. And I assume it's in also Western reading notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the 1 were here, this would have to be 9. Because that 9 is saying in box 1, the 1 has to be in the 9th position, the 9th index. Let's look at another example. Say the 5 was here. Then in box 5, the 5, this tells you the index of where the digit 5 is, so it would have to be 3. And that's the same for all of the boxes. We also have in box X, we already did that. Digits separated by a white dot are consecutive, so these are Kropke dots. So for example, if this were a 6, this would have to be a 5 or a 7 to make sure that those digits are consecutive. And finally, we have digits on gray squares are even. So these are all even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is obviously on the path, and it must be a 3. One of these 3 is a 1. If we go down here, actually, if we go up here or down here, the problem is, where can it be to get 4, 1? You can't, right? I guess it could be 3, 1, 4. Okay, it could go 3, 1, 4, 1 there. It cannot go 3, 1, 4, 1 or 3, 1, 4, 1 because that would be 1 in the same box no matter what. It cannot go 3, 1, 4, 1 because of the same problem. So this is always on the loop or on the path, and it's always a 1. So that means this has to be 8 to basically make sure that the index in this box of the 1 is in the 8th index. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 1 is only consecutive with 2, so this is 2. So it could be 3, 1, 4, 1 or 3, 1, 4. It cannot go here. 3, 1, 4, 1 that way. So it could be 3, 1, 4, 1 that way. And then this is 5, 9, 2. So that could be that way. So 3, 1, 4, 1, 5, 9, 2. That is valid. Or it could go 3, 1. It cannot go 3, 1, 4, 1 here or 3, 1, 4, 1 that way. It would have to go 3, 1, 4. So this is on the path, and it's always 4. That would mean this has to be a 1 no matter what. No, that's a 2, because that indexes where the 4 is. So this has to be 2, which means it cannot be 3, 1, 4, 1. It has to go 3, 1, 4, 1 here. This is on the path. So this is not on the path because it cannot touch itself orthogonally. Let's make these all blue. These cannot be on the path. If it goes that way, it would touch itself orthogonally. If it touches these, it would touch itself orthogonally. And it can't go in here and exit back out, so these are not valid to be on the path. It could actually go this way. Oh, no, but then it would touch itself orthogonally, so it cannot go here either. One of these is 5. We have a 5, 9, 2. Okay, so these are even. So this is 4, 6, and 8. This is 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay, so it cannot go 5, 9. Where are the possibilities to go 5 and 9? If this were 5 this way, that would be saying that the 5 has to be in the 5th position, but it's actually in the 1st. So 5 cannot go this way. 5 has to go this way. Then 9 has to go here. So this is the path because it cannot go here because it's blocked by the even digit. So this is 5, 9. And then we need a 2. 2 could not be here and 2 cannot be here because they both see a 2. Therefore, it must go this way, and this is 2. So this cannot be 2. This is part of the path. So it cannot touch orthogonally. If it tries to go here, it can't exit out. So therefore, the path can't go there. If it enters in this way, it would touch itself. So none of these are valid to be on the path. Okay. So we have 3.141592. We need a 6. These digits have to be 3, 6, 7, 8, and 3 and 8 cannot be here. So this is a 6, 7 pair, which eliminates 6, 7 in the rest of the box. This can't be 6 or 7. This is a 3, 8 pair. 3.141592. We need a 6. It could go back here. Oh, that touches itself. Right, so these cannot be on the path because it would touch itself. So it goes either 2, 6 or 2, 6 here. Either way, it cannot. So if it goes 2, 6 here or 2, 6 here, it cannot go here because the next digit is a 5. And this is even. So either way, it would have to go here, it would have to go here, and this would never be on the path then, no matter what. Okay. 3.141592. One of these is 6. So since one of these is 6, this can never be 6 here. Also, this sees both 6s, so this can't be 6 here. If this is 6 down here, that would say that's... Oh, this is 8. It still could be the case, then. This could be 8. If this is 6... If this is 6, this has to be 5 here. If this is 6, it cannot be 5 here. It would have to be 5 here. So then 5 is either here or here. So 3.141592. We have a 6 and a 5. We need a 3. So 3 could be here, here. So 3 possible 3s could be here. Any of these 3. Okay, so what can the reference of 2 be here? Where's the 5? 5 cannot be 5 or 6 here. So this can't, well, couldn't be anyways. Cannot be 2. So 5 can be in the 3rd position. Can't be 1 or 2 because of the 1, 2 here. Could be in the 3rd position, so this could be 3. Cannot be 4, 5, or 6. Could be 8 or 9. So this is 3, 8, or 9 here, referencing the 5. The 5 could be any of these. 2 cannot be either of these. 2 cannot be in the 2nd position, so 2 must be one of these 3. Therefore, this is either 3, 5, or 6. 3 cannot be in the 1st position, because that would reference itself, and then that would say 3 has to be in the 3rd position. 3 can't be in the 3rd position, so 3 can only be one of these 3, which means it's 2, 4, and 5 here. Where's 7? 7 cannot be in the 1st. Okay, so what are the remaining digits in column 1? We have 1, 4, 5, and 9. This is 4, 5, or 9. This is 1, 4, 5, or 9. That would mean if this is 1, 7 would have to be in the 1st position, which is not allowed. If this is 4, that would mean 7 is in the 4th position, which is not allowed. So 7 must be in either the 5th or the 9th position in the box. 8 can be in a lot of places, so that's not very restrictive. This again cannot be 1, 2, 4, so it could be 3, 6, 7, 8, 9, or 5. That's saying 6 can, so 6 cannot obviously be here, because if that's 6, that would say 6 is in the 6th position, but we already have 6 in the 1st position. So 6 could be here, 3rd position, 5th position, or 7th, 8th, 9th. Okay, that's still valid. If this is 2, 6, 5, and if it goes this way, it has to go 2, 6, 5. That would mean 5 is in the 9th position. If it goes 6, 5 here, that would mean this is not 6, so it's a 4, 8, 4, 8 pair, which eliminates 8 here. This 6, 5 would eliminate 6, 5 here, so that would have to be 3, and then therefore this would have to be 9 either way. So this is 9 either way, which makes this a 5. This can't be 5, this can't be 5. This can't be 9, so 6 cannot be here. Right, so if this goes 6, 5... Why do I have a 3 here? I don't get... Oh, it's the possibilities of where 3 could be. Right. Okay, so 3 cannot go here because that would be 6, 5, and 3, and that would eliminate all possibilities for that cell. So 3 could go here, 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 or here. If it goes 6, 5, 3, the problem is 6 is saying 8 has to be in the 6th position in this box, which would be here. But 3 is not consecutive with 8. Therefore, it cannot go this way. So it must be 6 here. 6 cannot be either of these. So it goes 6, 5. This is the path. It cannot go here, so this is not on the path. This cannot be on the path. It could go any of these 3 spots. 5 is in the 9th position. This is 6, which means this can't be 6. This is 7, which makes that 6. This can't be 6. Where is the 6 in this box, then? It has to be here. Because, so this is 3, then. This cannot be 3. So it goes either 3 here or 3 here. We're not sure which. So we have 3.14159265. We need a 3. 3 and another 5. So either way, if this is 3 or this is 3, it has to have a 5 here or here. Which means this cannot be 5 here. Which means, and this can't be 3 anymore. So 2 cannot be, 3 cannot be in the 2nd position. It cannot be in the 5th position or the 4th position. It has to be in the 2nd position in the box. So this is 3. This can't be 2 or 6. This can't be 2. That means 2 is in the 5th or 6th position here. So the 5 has to go to one of these. 3, 5. We need an 8. So it could go, one of these is 8. Well, if it goes 3, 5 here, it cannot be 8 here because this is 3, so that would be 8. So it'd have to go 3, 5, 8 if it goes that way. It could go 3, 5, 8 for either of these two, and those are still fine. Ah, where is the 3 in box 5? It cannot be any of these here. So it has to be one of these two, which means this cannot be 3. So this is 8, this is 3, which makes this not an 8, that's 4. So this can't be 4. 8 still cannot go that way. This path can never go here because then it would have to touch itself this way. So this is not valid to be on the path. You cannot go this way. So if it goes this way, okay, it can't double back. So if we tried to do 3.14159265 358, it would touch itself. So this is not valid. So it cannot go that way. It has to go this way. This is 3, which makes this a 3. Because 3 cannot be here or here. This has to be 5. One of these is 8. It cannot touch itself. So it can't touch itself by going back here. So it could be either of these. This is not valid to be on the loop or the path because it would touch itself going there. Same here. Same with these two. This has to be 1, 7, and 8. And 8 cannot be here. These can't be 1. Where is the 1 in box 5? It has to be here. This is a 7, 8 pair, which makes this a 5 here. This cannot actually go out here and go back. So these are not on the loop or on the path. So cannot be any of these. So it could go here, something like that. That's possible. Okay, what are the remaining digits? We have 8, 8, 9, 7, 9. So you cannot have. So if it's 8, you can't have going like this 8, 9, 7, 9. We have to go 8, 9, and 7. So 8, 9, 7. So that means 9 is one of these two. 9 has to be in the 5th spot position. So this is 9. And we must get to 7 then. So that's 7, and that's the end. Okay. 7 can no longer be here. Oops. Actually, this 5 means this has to be 9, which means, again, 7 cannot be here, which means it does have to be here. These cannot be 9. This cannot be 9. We have 4, 5 here. 1, 4, 5 here. 8 says 1 is in the first slot. 5 or 6 says 2 is in the 5th or 6th position. 2 says 3 is in the 2nd position. 2 says 4 is in the 2nd position. 9 says 5 is in the 5th position, 9th position. 3 says 6 is in the 3rd position. 9 says 7 is in the 9th position. What about here? This cannot be 2, 4. It can't be 1. If this were 1, that would say 8 is in the 1st position. So it could be 6, 7. It cannot be 8. Right? So if this is 6, that's interesting. Okay. These cannot be on the path. This cannot be on the path. If this is 6, that says 8 has to... Okay, so this can never be 8. Because it can't be in the 2nd position. If this is 6, this is saying 8 has to be here. And 8 can only be consecutive with 7 or 9. So 8 cannot be here. Which means 8 has to be in the 7th position. So this is 7. This 8 eliminates 8 here, so this is 6, which makes that a 5. That says 2 has to be in the 5th position, so this is 2. This cannot be 2. Remaining digits are 1 and 3 in column 4. But this can't be 3 because of this 3, so this is 1, this is 3. These digits are consecutive. You cannot have 1, 2, 2, 3, 3, 4. You could have 4, 5 as long as this is 5. So 5 and 4 work. 6 and 5 work as long as this is 6 and this is 5. 7, 8. No 6, 7, no 7, 8, no 8, 9. So this has to be 5. The remaining digits here, this 2 eliminates 2 here. So this is 4, which makes this 6. This can't be 2 because of the 2 in the column. So this must be 9. This is 2. This can't be 1 or 5, so this is 4, which makes this 5, which makes that a 1. Now we just probably do Sudoku, mainly. We have this still, too. Remaining digits in column 5. We have 1, 7, and 8. This can't be 1, so this must be 7 or 8. This must be 1. In column 6, we have 4, 9, 7, 8. This can't be 8. These digits are consecutive. If this were 4, it has to be with 3 or 5, but that's eliminated by the 3 and 5 in the row. If it's 7, it could be with 6 or 8. Neither of those work. 8 can be with 7 or 9. 9 can be with 8. So those all work. Where's the 1 in row 2? Can't be here because of the 1 in the box. Can't be here because of the 1 in the box. This is consecutive with that, so that's eliminated there. This is even. Therefore, this must be 1. The remaining digits in row 5 are 2, 7, 9. And this can't be 2, this can't be 9, this can't be 7 because of the digits in the column. The digits here in row 6 are 1, 4, and 8. And this can't be 1 because of that 1. Digits in row 8 are what? 2, 8, and 3. Well, this can't be 2 or 3, so it must be 8, which forces that to be on the path, and this cannot be on the path, and is some other digit. So this is 2 and 3, but this can't be 2 because of the 2 here, so this is 3, this is 2. This 8 eliminates 8 here, which means this can't be 9 because these digits are consecutive. We have a 7-8, 7-8 pair in column 6, which eliminates 7, 8 in the rest of the column. This can't be 7 or 8. This can't be 7. We have what remaining digits in column 3 are 4, 6, and 8. Well, 8 cannot be either of these cells because of 8 in the box, so this must be 8. This is a 4, 6 pair here. That leaves this remaining digits as 7, 9. That leaves these digits as 3 and 5. No, not 3 and 5. 6 and 5. And 5 cannot be here, therefore this is 6, this is 5. Remaining digits here are 1 and 2. 1 can't be here because of the 1 in the column, so this is 2, this is 1. This can't be 1. Where is the 1 in row 6? It must be there. This 2 eliminates 2 here, so this is 7, 9, and 2. This 9 means this can't be 9 here. Remaining digits in row 9 are 3, 4, and 6. This can't be 3 because of those 3, therefore this is a 3. This is 4 or 6. That's 3 in the corner. We celebrate because we know we're getting close to solving this. Where is the 5 in row 3? Cannot be any of these two because of the 5's there, therefore this is 5. We have a 4, 8, 4, 8 pair. That leaves only 9 left in row 9. So this is 9, which makes that not 9. So this is 4. This 9 eliminates 9 here. So that's 7. That makes this a 6. This is 4. This is 9. This has to contain a 7. This is 4, which makes this an 8. Therefore, this is 7, 6. The 7 eliminates 7 here. So this is 8, 7, 8. This 4 eliminates 4 here. So this is 9. This 6 eliminates 6 here. So it's 4, 6. 8 makes this a 4, which makes that an 8. That leaves this as a 4 and this as a 7. Pretty cool, actually. Interesting. The indexing with the upper left corner is interesting. It does restrict things quite a bit. And enough to basically, along with the pi path, essentially solve this puzzle from, scratch, essentially. Pretty cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.